condense the logarithms, or in other words, combine all these logarithms into a single logarithm by using the properties of logarithms. Okay, let's get to it. First thing you need to do is, if you see coefficients in front of the logarithms, you can move those inside of the logarithm as an exponent. So this 3 right here, we can move it inside. These 2 and this 3. So it's going to become like this. Logarithm of x squared y, and the 3 goes inside as an exponent, so cubed. Plus, now is going to be logarithm of 2 over x. These 2 goes inside as an exponent, so squared. And lastly, the 3 goes inside as an exponent, so this would be y squared cubed. Okay, now using the properties of exponents, we simplify this. This will be logarithm of what? X to the 6th, and then y cubed. Right, you multiply the exponents, plus logarithm of, now you square in a fraction, so that means you square the numerator and you square the denominator. Squaring the numerator, that would be 2 squared, which is 4. Squaring the denominator, that would be x squared. And lastly, using, again, the properties of exponents here, that would be y to the 6th. Because exponents that are back to back like this, you multiply them. Okay, now, you may take these 2 logarithms and combine them into one, because the sum of 2 logarithms is the logarithm of the product. So in other words, this is the logarithm of the product. The product of x to the 6th y cubed times 4 over x squared. Alright, and now what is this? Well, you can multiply across, and then you can combine or simplify. So this is going to be 4x to the 6th y cubed multiplying across over x squared. And we're going to need to simplify this, okay? Combine the x's. We're going to do that in the next step. Minus log of y to the 6th. Now let's combine here. What do you get there? You combine those x's. You will get 6 minus 2 is 4, so you would get x to the 4th. X to the 4th y cubed. Okay, I think in 2 more steps we probably can finish this. Now, the difference of 2 logarithms is the logarithm of the quotient. So this is going to be logarithm of 4x to the 4th y cubed over y to the 6th. And now to finish it off, we need to simplify that. Combine those y's. So subtracting the exponents, 3 minus 6 is negative 3. The fact that it's negative means you just put it in the bottom. Without the negative, of course. Because the negative just tells you it's a bottom. So 4x to the 4th over y to the 3rd. And that would be the end. Expand the logarithm. So now we want to take this logarithm with a complicated argument and express it and expand it into simpler logarithms using the properties of logarithms. Okay, whenever you have a quotient inside a logarithm, The logarithm of the quotient is the difference of the difference of the logarithms of the numerator and the denominator. So this is going to become logarithm of the numerator minus logarithm, natural logarithm, ln, of the denominator. Okay, ln of the top minus ln of the bottom. Next, whenever we have products inside a logarithm, that becomes the sum of the logarithms. And I have actually two products here, 10 times x to the 6 times z. So we're going to split all of these up into sums of logarithms. So this would be ln of 10 plus ln of x to the 6 plus ln of z minus ln of y cubed. And lastly, the last thing we do is any exponents inside, like this one, you would move them to the front as coefficients. So we would get ln of 10 plus 6 ln of x plus ln of z minus 3 ln of y. And that would be the final answer. Solve the equation. This is an exponential equation because the variables are in the exponent part of the expression. Remember, the trick for solving exponential equations is to bring the exponents down by taking ln on both sides. So the first thing we're going to do is take ln on both sides. This is going to be ln of e to the 3x plus 4 equals ln of 6 to the 2x minus 1. Now that is going to bring the exponents down because one of the properties of exponents is you can move those exponents to the front, outside of the logarithm. So this is going to become 3x plus 4 ln of e equals 2x minus 1 ln of 6. Now ln of e is 1. Ln of e is 1. So you need to remember that. Ln of e is 1. So using that, then, this is just 1. So the left-hand side would be just 3x plus 4. Which equals 2x minus 1 times ln of 6. Now, I want all the x's on the same side of the equation, so I can solve for x. But before I can move this, this is trapped inside that parentheses. I need to get it out of there. So that means we need to distribute that. So this reading on the right-hand side, we would get 2 ln of 6x. Okay, 2 ln of 6x, and then minus ln of 6. You can write 2x ln of 6, it really doesn't matter. But remember that typically we write the x after the numbers. But writing 2x ln of 6 is fine. Okay, then now we can move this term to the left. So this will be 3x minus 2 ln of 6 x, and then move the 4. So this will be negative 4 minus ln of 6. Okay, and then the x is repeated, or is a common factor, so you can factor it out. So we get 3 minus 2 ln of 6 x, so I factored it out, equals negative 4 minus ln of 6. And lastly, divide both sides by this thing to get the x all by itself. So you would get x equals negative 4 minus ln of 6, all that over 3 minus 2 ln of 6. So that is the final answer. That is what x is. They might ask you to enter it in a calculator and round your answer to 2 decimals or 3 decimals or whatever. But if they ask for the exact answer, that is the exact answer. Now, personally, I really do not like the fact that there's so many negatives in there. So I would simplify this a little bit differently. I would factor out a negative from the top and a negative from the bottom. When you factor out a negative from the bottom, this would be negative 3 plus 2 ln of 6. And how do you know that's true? Well, if you distribute, you get this back. Negative and negative gives you positive 3. Negative and positive gives you negative. And then you could cancel those negatives. And that's a little bit better because, I mean, personally, there's fewer negative signs. Okay, and you can write it like this. And that looks slightly better. Okay, but both are correct. Solve the equation. This is a logarithmic equation because the variable is inside a logarithm. There's two ways of doing this, and I'm going to do it one way and just tell you then what's another way of doing it. But what we could do here is combine these two logarithms into a single one. Generally speaking, we want as few logarithms as possible. So we can combine them using the properties of logarithms. Now, condensing the two on the left, we could get, well, the sum of the logarithms is the same as the logarithm of the product. So this is the same as the logarithm, natural logarithm of the product. Okay, so you multiply that and that. Okay, and then distributing here, this would be 2x squared minus x. So you have the natural logarithm of 2x squared minus x equals the natural logarithm of 15. Whenever you end up with a situation like this, where you have two logarithms with the same base, equal to each other, so you have ln of this equals ln of that. When you have two logarithms equal to each other, like this, that means that the insides have to be equal to each other. That's because the natural logarithm, in fact, all logarithms are 1 to 1. So if you have two outputs that are the same, the inputs have to be the same. So that means 2x squared minus x equals 15. Okay, the insides have to be the same. And now this is a quadratic equation that we can solve any way we want. I'm going to move the 15 to the left and see if we can factor that. If not, you have to use the quadratic formula. Let's see if we can factor this. If we put here 3 and 5 minus and plus, I think that's correct. Yes, you can check. That's correct. If not, just use the quadratic formula. Okay. All right. Now set each of the factors equal to 0 for x minus 3 equal to 0 and solve each of these. This one gives me x equals negative 5 halves. And this one gives us x equals 3. Finally, remember that for logarithmic equations, you cannot just end it there. You have to check that they're part of the domain, meaning that when you plug them back in here, you do not get a negative inside the logarithm, because having a negative inside a logarithm would give you error. It's nonsense. It's not part of the domain. So just make sure that when you plug them in here, you don't get a negative number inside the logarithm. So let's start by plugging the 3. If you plug 3 in here, you will get 2 times 3 minus 1. That's 6 minus 1, which is 5. 5 is not negative, no problem. And then here, 3, you will get 3 inside the logarithm, which is not negative, no problem. So that means this one actually checks. Now let's check the other one. Negative 5 halves. If you plug in negative 5 halves here, minus 1, you will get that this inside would be negative 6. This would be negative 6, and this one would be negative 5 halves. So you would have negatives inside logarithms. That's not allowed, okay? You cannot plug in negatives inside logarithm. So this is not good. So you have to discard that. That means the only answer is x equals 3. Now, as I said, there's another way of doing this one, and that is just combine all 3 logarithms on the left-hand side of the equation and use the diagram to decode this. Once you have all logarithms combined into a single thing on the left, such as this, then you can use a diagram. B to the y equals x. B to the y equals x. And you would have an equivalent equation that doesn't have any more logarithms. Solve the logarithmic equation logarithm base 4 of x minus 9 equals 2. Okay, for solving this, we're going to use the diagram of how to interpret logarithmic equations or logarithms. So right now then, we're going to use this diagram to decode this. What does the diagram tell me? I'm going to write this bigger. This would be equivalent to 4 to the 2 equals x minus 9. The base to the 2 equals the inside of the logarithm. So this would be 4 to the 2 equals x minus 9. Or in other words, 16 equals x minus 9. And adding 9 on both sides, we get 25 equals x. And now make sure that when you plug it back in here, you don't get a negative inside the logarithm. 25 minus 9 is positive 16, and positive 16 is not negative, obviously. So that means this is correct. This answer works. That's the answer.